Hello everyone. In this video, I'm going to talk about how to balance chemical reactions. Please understand we do have several methods to balance chemical reactions, and I'm going to apply one of the most commonly used methods to balance about 15 examples in this video. Hope it helps you to understand and easily balance all questions regarding the balancing. First, I'm going to introduce this method. This methodology is going to be super easy. Whenever you are going to balance the chemical reactions, you just need to balance based on this ordering. First, balance metals, then nonmetals, hydrogen, and finally oxygen. Please remember that if we are going to balance metals, nonmetals, hydrogen, for most of the examples, oxygens are going to be balanced at the end without any other steps to balance oxygen separately. So I'm going to focus on a couple examples at the beginning, then we are going to apply that one for a little bit more advanced example. I'm going to start with this example. Na2S plus H2S produce NaSH. First, I'm going to balance metals. Metals, in this example, we have only sodium, 2 sodium atoms. So on the right side, we need to make same number of sodium. So I'm going to multiply by 2. 2 sodium atoms on the left, 2 sodium atoms on the right. Then I am going to balance non-metal, except hydrogen and oxygen. So the non-metal here is sulfur. Look here, we have one sulfur atom here, and we have another sulfur atom from the H2S. So totally, on the left side of the reaction, we have 2 sulfur atoms. 2 sulfur atoms on the reactant side, we need to make 2 sulfur atoms on the product side. As you see here, this number, this coefficient, belongs to all elements in the chemical formula. 2 not only belongs to sodium, but also belongs to sulfur and hydrogen as well. So right now, it looks we have 2 sulfur atom as well. So it looks sulfur atom already balanced. I'm going to balance hydrogen, the next step. 2 hydrogen atoms on the left. So on the right side, we have 2 hydrogen atoms because we have hydrogen here with this coefficient. It means 2 hydrogen atoms. So it looks we have a balanced equation. Whenever we say balanced equation, we are going to remember that we apply the coefficients. Coefficients in general are whole number or an integer numbers. Whenever we are going to work on the numbers, if we don't have a coefficient here, we imply that this coefficient is 1. 1 for Na2S, sodium sulfide, 1 for H2S, and we have 2 for NaSH. Whenever we have 1, we don't write 1 and we just apply for the number greater than 1. I always ask you, please, before submitting, you just need to double check all elements in the formula in the reactions to make sure they are balanced. To do that, I may ask you to just apply the check mark. 2 sodium atoms, 2 sodium atoms. Sodium is balanced. Sulfur, 1 sulfur plus another sulfur, 2 sulfur atoms. We have 2 sulfur atoms here. So sulfur atoms are balanced. Then hydrogen, 2 hydrogen atoms. Here we have 2 hydrogen atoms. So hydrogens are balanced. So whenever all elements are already check marked, at that time we have balanced equation. So please understand we need to have simplest whole number or simplest numbers for balancing, for coefficients. If I write something like this, 2Na2S plus 2H2S, it gives us 4NaSH. So this is a balanced equation. 2 times 2, 4 sodium, 4 sodium. 2 times 2, 4 hydrogen, 4 hydrogen. Number of sulfur, 2 sulfur atoms plus 2 sulfur atoms. 4, we have 4 sulfur. But we don't accept that one because of the coefficients. We need to report the simplest possible coefficients for a series of compounds. So please understand, we don't accept 4, 2, 2, and 4, and we divide by 2. It means 1, 1, and 2. Let me work on another example. So the example I'm going to share with you is this example. Li plus N2, it gives us Li3N. We are going to balance first metals. 1 lithium, 1 lithium. No, we have 3 lithium. So it means we have to apply 3 lithium here. So this coefficient makes 3 lithium. Number of nitrogen. 2 nitrogen here. We have 1 nitrogen here. So we need to make 2 nitrogen for this one. I multiply by 2. 2 nitrogen. So I already balanced nitrogen. I ask you before leaving the problem, just double check to make sure everything is balanced. 3 lithium, but we have 2 times 3, 6 lithium atoms. Please understand, whenever you are going to count number of atoms, coefficient multiplied by subscript. So in this example, coefficient multiplied by 3. So we do have 6 lithium atoms. So I have to change that one to number 6 to make same number of lithium. 6 lithium, 2 times 3, 6 lithium. So lithium is balanced, 2 nitrogen, 2 nitrogen, because this number belongs to nitrogen as well. So please remember, whenever we are going to count number of atoms, coefficients multiply by subscript. Let me work on another example. Al plus HCl makes AlCl3 and H2. I'm going to balance this equation. So first metals, 1 aluminum, 1 aluminum. Then non-metal, except hydrogen and oxygen. So I have to start with chlorine. 1 chlorine, 3 chlorine. So I multiply by 3. 3 chlorine atoms, right now 3 chlorine atoms. Next, I have to balance hydrogen. 3 hydrogens, 2 hydrogens. Let me write the number of hydrogen here, 3 hydrogen atoms, and here we have 2 hydrogens. Whenever you have even and odd numbers, like this, 2 and 3, you just need to switch the numbers. It means you just need to write 2 here for this substance and 3 here for this substance. Switch the numbers. Here we do have 3. So whenever you are going to apply 2, you just need to multiply. 2 times 3. So let me write that one as 6. And here I'm going to write 3 here. There is no number, so you can easily write 3. So I'm going to count number of hydrogens. Right now we have 6 hydrogen atoms, and 3 times 2 we have 6 hydrogen atoms. So it looks we balanced our reaction. I'm going to ask you please double check to make sure this is a balanced reaction. 1 aluminum, 1 aluminum. Aluminum is balanced. Next, number of chlorine, 6 chlorine atoms, but here we have 3 chlorine atoms. So we have to multiply by 2. I multiply by 2. 2 times 3, 6 chlorine atoms. I am going to check aluminum one more time because I am going to change the number of aluminum as well. So let me double check aluminum again. 1 aluminum, 2 aluminum. So I have to multiply by 2. 2 aluminum, 2 aluminum. Right now is balanced. 6 chlorine, 2 times 3, 6 chlorine. This is the balance. 6 hydrogen, 3 times 2, 6. So right now I have balanced chemical equation. You can easily do that one whenever we have like a reaction like this one. So because they are similar, I may ask you to work on this one. You may pause this video and work on this. Na plus HCl. It gives us NaCl plus H2. So first metal 1, 1, chlorine 1, chlorine 1, hydrogen 1, and 2. So I multiply by 2. 2 hydrogen, 2 hydrogen. Double check from the beginning. 1 sodium, 1 sodium. 2 chlorine, we have 1. So we multiply by 2. So I have to back and double check because I changed the number of sodium. Number of sodium 1, 2. I multiply by 2. 2 sodium, 2 sodium. Balanced. 2 chlorine, 2 chlorine. Balanced. 2 hydrogen, 2 hydrogen. So all elements already balanced. So you don't need to be worried regarding that part. And let me give it you another example like this. Fe plus O2, it gives us Fe2O3. First metal, we multiply by 2 because 2 Fe, 2 Fe, oxygen 2, oxygen 3. Even and odd numbers, switch the numbers. 3 here, and I'm gonna write 2 here. So 3 times 2, 6, 2 times 3, 6. Oxygen is balanced. I'm going to double check. Fe, 2 Fe, 2 times 2, 4 Fe. So I have to change that one and I write this number, 4. 4 Fe, 4 Fe. 6 oxygen, 6 oxygen, because 2 times 3. 1, 2, 3, 4, 5 examples in this slide. I'm going to ask you, please remember, metal, nonmetals, hydrogen, oxygen. On the next slide, I'm going to change the level of the questions. Assume that we don't have metals, and we are going to work like this example. N2 plus O2, it gives us N2O3. If you remember, I told you we just need to start with metal, then non-metal, hydrogen, at the end oxygen. As long as we don't have metals, we start with non-metal. Non-metal here is nitrogen. 2 nitrogen, 2 nitrogen. And oxygen 2, oxygen 3. 2 and 3. Even and odd numbers. Switch the numbers. 3, 2. 3 times 2, 6. 2 times 3, 6. Number of nitrogen. I'm going to balance them. 2 nitrogen, 4. So we multiply by 2. 2 times 2, 4. 2 times 2, 4. 3 times 2, 6. 2 times 3, 6. Let me work on another example. Let me give it you like this one. N2H4 plus O2. Let me write the product like nitrogen and H2. Again, we do not have metals. So in this slide, I'm gonna show you if we don't have metals, how it works. So we start with non-metal, nitrogen 2, then hydrogen 4. We multiply by 2, 2 times 2, 4. Number of oxygen, 2 oxygen, 2 oxygen. Double check. Nitrogen 2, hydrogen 4, 2 oxygen, 2 oxygen. I'm sure you can easily balance like this example. Let me write that one for you. Same. I'm gonna switch the one of the substance to chlorine. I may ask you to pause this video, balance this one, and double check. If you do that, we have like this: 2 nitrogens, 4 hydrogens, we multiply by 4. 4 hydrogens. Then number of chlorine. Let me double check. Let me back. So 2 nitrogen, 2 nitrogen. Another nonmetal is 2 chlorine. I multiply by 2 chlorine. 2 chlorine, 2 chlorine. Number of hydrogens 4. This is 2. I have to check that one to 4. I could say same, but we prefer to apply this method to make sure we are going to work on a systematic method. 4 hydrogen, 4 hydrogen. Number of chlorine, 4. Here we just need to change B to 2. So let me double check. Nitrogen 2, nitrogen 2. Chlorine 2 times 2, 4, 4. Hydrogen 4, and this is 4. Let me give it you another example. What example? It was like this one. In H4, NO3, it gives us N2O plus H2O. I wanted to give you the very similar to the first. Please understand, in this compound, we have nitrogen. It appears in ammonium nitrate. 2 nitrogen on the left side. So we have 2 nitrogen on the right side. Number of hydrogen, 4. We have 2. We multiply by 2. 2 times 2, 4. Number of oxygen, 3. So here we have 1 oxygen plus 2. 2 oxygen here plus 1. Totally we have 3 oxygen. Same like this one. So it looks this is a balanced reaction. Double check again. Number of nitrogen, 2. 2. Number of hydrogen, 4. 2 times 2, 4. And number of oxygen, 3. 1 plus 2. We have 3. And let me give it you this one. Let me give it you not this one. P4 Cl2 PCl3. Easy example to work on. Number of non-metal. We don't have metals. 4 phosphorus, we multiply by 4. Chlorine 2, 4 times 3, 12. So we multiply by 6. 6 times 2, 12. 4 times 3, 12. So double check. 4, 4, 12, 12. So this is another 5 examples in this slide. So in the last slide, I'm going to apply if we have metals and polyatomic ions, like this one. Na plus MgNO3 twice. It gives us NaNO3 plus Mg. Again, please remember that one. We are going to apply metal, non-metal, hydrogen, at the end oxygen. Whenever we have polyatomic ions, I'm going to give you this step to balance the equation quickly, faster. You just need to do like this. First, we start with metal. 1 sodium, 1. Then another metal, 1 magnesium, 1. Then we have our non-metal, N. So N in the parentheses 2, it means 2 nitrogen. So I have to write it 2 here. Then number of oxygen, 2 times 3, 6. Number of oxygen, 2 times 3, 6. But as we saw here, I balanced nitrogen as a non-metal and oxygen as at the end in 2 different steps. But I'm going to show you how to balance polyatomic ions in one step. Whenever we balance sodium and magnesium, we are going to balance N, nitrogen. But we see that nitrogen belongs to this polyatomic ion, NO3, nitrate, and it appears here on the right side. we assume that nitrate acts like a unit. So we have two, look here, NO3 twice. We have two nitrate. So on the right side, we have only one nitrate. So I'm going to multiply by 2. So by this method, you are able to balance polyatomic ions quickly. I'm going to double check. 1 sodium, 2 sodium. I multiply by 2. Double check to make sure everything is correct. 2 sodium, 2 sodium. Magnesium 1, magnesium 1. And whole NO3, 2, because it is a parenthesis, and 2 belongs to NO3, and we have 2 NO3 because this number belongs to NO3 as well. So we balance NO3 as a unit. Right now, I'm going to focus on this example and work on some practice problem like this one. Al2SO4 3 plus CaCO3. We are going to balance this one. CaSO4 plus Al2CO3 3 times. Again, we start with metals first. 2 aluminum, 2 aluminum. Another metal is here. Always at the beginning of the formula, we may find metals. 1 calcium, 1 calcium. Metals are balanced. Then we start with non-metals. But we looked at SO4 sulfate. And on the right side, we have SO4 sulfate as well. So on the left side, we have 3 SO4. Please look, we have 3 SO4. So I'm going to write 3 SO4 here. Then I'm going to balance carbonate, CO3. On the right side, we have CO3 in the parentheses, and we have 3 CO3, 3 carbonate, so I have to multiply by 3. Let me double check to make sure everything is balanced, because I already balanced all of the elements. 2 aluminum, 2 aluminum. 3 calcium, 3 calcium. SO4, 3, SO4, 3. 3 carbonate, 3 carbonate. As you see here, we count number of elements or number of group of elements by coefficient or by subscript. And if we have both of them, we multiply by each other. Let me work on another example. MgCl2 plus K3PO4. So it gives us KCl plus Mg3PO4 twice. I may ask you to pause this video and balance this equation. I'm back here and double check. So to balance this reaction, first metals, 1 magnesium, 3. Wow, we need to balance magnesium by this coefficient 3. Then potassium 3, so we multiply by 3. We have chlorine, 3 times 2, 6 chlorine atoms. So here we have only 3. I'm gonna check that one. And I write 6 chlorine atom right now. I continue. I wanted to continue to balance the other nonmetal. The other nonmetal here is phosphate, PO4. And we see PO4 on the right side. 1 PO4 on the left, 2 PO4 on the right side. So I'm going to back and multiply this one by 2. 2 PO4 and we have 2 PO4. Right now, this is the time to double check. 3 magnesium, 3 magnesium. 2 times 3, 6 potassium, 6 potassium. 3 times 2, 6 chlorine, 6 chlorine. And 2 phosphate, we have 2 phosphate. If you don't want to balance the phosphate, carbonate, sulfate, nitrate, or any other polyatomic ions, and you prefer to separately balance the elements like phosphorus separately, oxygen separately, you can easily do that. So, for example, you can say 2 times 4, 8 oxygen, 2 times 4, 8 oxygen, 2 times phosphorus, 2. Here we have 2 phosphorus. So you can easily make like this one. I'm going to ask you to balance this equation by yourself. I'm sure you can easily balance this equation. So you may say 3 lithium, we multiply by 3, aluminum 1, aluminum 1. Then you are going to balance the polyatomic ion. PO4, so you have PO4. It's balanced. Then you are going to balance NO3, 3 times NO3, here NO3, and this number 3. So look, it's already balanced. So you may say 3 lithium, 3 lithium, 1 aluminum, 1 aluminum, 1 phosphate, 1 phosphate, 3 nitrate, and look, 3 belongs to all elements here, 3 nitrate. So this is another 5 examples I wanted to share with you. Hope this video helps you to understand how to balance chemical reactions by disordering metals, nonmetals, hydrogen, oxygen. Thank you for watching this video.